This is a Fox San Antonio special.
It's a bit of a misnomer to refer to average precipitation in south central Texas. It's never average. You have 2 years of drought followed by 6 weeks of flooding. So that's a bit of an exaggeration, but it's close to reality.
The pattern of drought flood is nothing new to Texas. Weather and climate records show the pattern as far back as the late 1800s. Records back to 2000 show the pattern in detail. So, what is the cause of this dry, wet pattern? Our search for an answer takes us 3,200 miles to the south, in the Pacific Ocean, off the coast of Peru. Here, you will find one of the most important climate phenomena on the planet, the El Nino Southern Oscillation. This unique feature has the ability to change global atmospheric wind patterns, which in turn helps change temperature and precipitation patterns across the planet. The Earth is sometimes called the ocean planet, and for a good reason. The ocean covers 71% of the Earth's surface and contains 97% of the Earth's water. The largest ocean is the Pacific. All the continents and almost all the other oceans would fit inside this body of water. The Pacific is also the deepest. The world's tallest mountain, Mount Everest, at about 29,000 feet, would sink more than 1.5 miles below the surface of the Pacific in the Marianas Trench at 36,200 feet below the surface. The ocean's influence in climate is incredible. It does it in several ways. It absorbs solar radiation and releases heat that drives the atmospheric winds. It releases particles in the air, like sea salt, that influence cloud cover. It absorbs carbon dioxide from the atmosphere, and more importantly, releases water into the atmosphere through evaporation to make rain that falls on the land. The oceans are an important influence on Earth's weather and climate.
In south central Texas, when we are in a La Nina across the equatorial Pacific, that typically tilts the odds towards a drier and warmer winter and spring here in south central Texas. When we are in an El Nino, that tilts the odds in the winter and summer months towards a wetter and cooler pattern.
So how do things stand in the Pacific Ocean right now?
So it's tied towards the sea surface temperatures in the equatorial Pacific. When they are cooler than normal, we are in a La Nina. When they are warmer than normal, we are in an El Nino. So right now we're in a weak La Nina. Typically, on average, we see drier than normal conditions and warmer than normal conditions with La Ninas.
The atmosphere and the surface of the ocean are connected. Changes in the ocean impact the atmosphere. Changes in the atmosphere impact the ocean. These changes create a back and forth pattern. Warm El Nino, cold La Nina. And it happens every 3 to 4 years. When the easterly trade winds strengthen, they create a westward flowing current on the ocean surface. This sends warm surface waters westward and pulls deep cold water from the bottom to the surface. And it happens off the west coast of South America in a process called upwelling. Upwelling can cause a dramatic drop in sea surface temperatures, creating what we call La Nina. A typical La Nina lasts about 9 to 12 months. However, some have lasted as long as 2 years. Data from the National Center for Environmental Protection show La Nina events recorded all the way back to 1903.
1954 to 1956, our strongest La Nina on record, and you can see some of our driest years here in San Antonio on record. 2008, another La Nina event, a very dry year. 2011, our worst one-year drought in Texas history, our 14th driest period here in San Antonio out of 132 years. So certainly our driest years are normally tied towards the La Nina events that we have.
Drought is not only caused by La Nina, the lack of rainfall, and higher than normal temperatures, it's also caused by ever-growing population centers and their demand for water. It's also made worse by the overuse of the limited surface water supply that we have.
You ask what can be done around here, you have to live within your means, and that may require changing habits and patterns and the way people tend their gardens and their yards.
Drought can actually mean different things to different people. Certainly you have impacts in the agricultural sector, you can have impacts over a long period of time in the hydrologic and ecologic sectors, and then you can have impacts on the wildfire side, so it means different things to different people.
Drought is one of the most costly types of natural disasters in the country. This weather event has an average yearly cost of $9.4 billion. Drought impacts more than just the environment. It impacts the economy and the society by creating water shortages, limiting food supplies, destroying habitat, and enhancing the development of wildfires and triggering health and safety problems. Every week, drought experts check the drought status of regions across the country and publish the U.S. Drought Monitor.
So there's different ways we can measure drought. Again, it means different things to different people. The U.S. Drought Monitor tries to capture all the different aspects of drought. The long-term drought, the short-term drought, the agricultural impacts, the hydrologic impacts.
The Drought Monitor is developed from examining a number of factors. Each map that is published is reviewed by several hundred experts across the country and validated as accurate as possible.
The U.S. Drought Monitor is a collaborative effort, so we look at short-term rainfall deficiencies over the last 30, 60, 90 days. Then we look at long-term rainfall deficiencies over the past 6 to 12 months to beyond. And then we look at the actual impacts that are being realized. How are our crops doing? Are there losses in the agricultural sector? How are our reservoirs doing? How is the Edwards Underground Aquifer doing? How are the wildfires doing? So we combine all that into one index and you get the U.S. Drought Monitor.
Most of us think about drought as an extended period without rain. However, drought can mean different things to different people. Droughts can strike any region of the country at any time.
Trying to predict droughts and their duration is a challenge. There's a number of efforts underway to help bring some understanding to that, but it's just a huge problem trying to plan ahead for water resources in south central Texas because of the high variability in rain events.
And as we learned, our droughts are closely tied to El Nino Southern Oscillation, a cycle that can be traced back to the late 1800s.
So I like to refer to our climatology in south central Texas as drought interrupted by short periods of floods. When you go back in history, you see all the way back as far as our records can go, you see periods of drought. Sometimes they last a few months, sometimes they last decades. So the worst kind of long-term drought in Texas history was the drought of the 50s. Started around 1950, went through 1957. Here in the San Antonio area, we averaged annually through that drought about 18 to 19 inches of rainfall a year, where we should have been up around 32 inches.
Texans have come to expect drought. During every decade of the 20th century, drought was impacting a part of the state. In 1917, only 15 inches of rain fell across the state.
During a drought, you have less water that's being evaporated up into the sky. You have less precipitation that's falling back towards the ground and being absorbed back into the ground. If you have less moisture in the ground, eventually you have less that evaporates back up into the clouds. And so the whole process feeds off of itself, and it usually takes some big event to break that process.
And when La Nina fades and El Nino returns, we do get those big rain events.
And that happens because you have these storms coming from the west, you have these storms coming out of the Gulf, you have storms coming out of the east, and they park right over this area. And when they stall, you can get 20 inches of rain in 24 hours.
Texas cities depend on aquifers and groundwater for their water supplies. About 60% of all Texas water comes from aquifers, and about 40% from groundwater. Texas is the second biggest user of groundwater in the country, second only to California, using as much as 38,000 million gallons per day, with most of the water being used for irrigation.
There's no untapped water to any extent in Texas. If you're going to move to the headwaters to capture water, you're going to be interrupting water that would otherwise flow downstream to other uses.
Trying to plan for those extremes is difficult, and it's also expensive because you've got to have a supply that can be assured of water throughout a drought like the 10-year drought in the 40s and 50s.
There's very little you can do without water. It's a precious resource, both for consumption and the way you treat the water after it's been used. Fresh water is just the source of life and the cornerstone of our existence. Precipitation is oftentimes talked in terms of average amounts. Average amounts in semi-arid areas like West Texas don't mean a lot because an average amount rarely occurs. What you have are periods of excessive precipitation for weeks or maybe months at the most, followed by months or years of less than average precipitation. And that makes planning very difficult.
The pattern of flood drought, is tied to a seesaw motion of currents in the South Pacific, known as El Nino Southern Oscillation.
In south central Texas, when we are in a La Nina across the equatorial Pacific, that typically tilts the odds towards a drier and warmer winter and spring here in south central Texas. When we are in an El Nino, that tilts the odds in the winter and summer months towards a wetter and cooler pattern.
Right now, sea surface temperatures are below average across the central and the eastern Pacific Ocean. This is a signal that La Nina is present. Forecasts show that there is a 95% chance that La Nina will last into March with a transition to a neutral phase during the months of April, May, and June. Rain has been in short supply for the past several months, another indicator that La Nina is present. A majority of our water supply is dependent on the Edwards Aquifer. The primary measure of that supply is the J17 well. Historical data from that well paints a clear picture of a drought flood pattern as far back as the 1940s.
1954 to 1956, our strongest La Nina on record, and you can see some of our driest years here in San Antonio on record. 2008, another La Nina event, a very dry year. 2011, our worst one-year drought in Texas history, our 14th driest period here in San Antonio out of 132 years.
It's a bit of a misnomer to refer to average precipitation in south central Texas. It's never average. You have 2 years of drought followed by 6 weeks of flooding. So that's a bit of an exaggeration, but it's close to reality.
Indeed, it is closer to reality than some would think. The deep drought of record in the 1950s can be clearly seen as a massive drop in the aquifer that began in May of 1949 and bottomed out in July of 1956. There would be 4 other dry periods between 1962 and 1971. 12 years later, a 4-year La Nina pattern would send the aquifer diving to one of its lowest levels ever recorded. There would be 3 more dry periods before 1996. Another downward trend in our water supply began in 2007 and bottomed out in 2015. The impact of El Nino Southern Oscillation on the aquifer is apparent. While we all look to the aquifer as our primary supply, it is important to remember
Natural systems don't retain that much water. In particular, carbonate aquifers like the Edwards, the Edwards Trinity do not retain a lot of water. Those aquifers are very good at conveying large quantities of water very quickly, but they don't retain water for long periods of time.
The Edwards aquifer is very much like a large sponge that has a system of connecting pipes that allows water to flow to the surface and make it to the springs and wells. While there is a big water supply in the aquifer, only the top 5 to 10% of it is available for use. While the Edwards aquifer is a big part of our water supply, our dependence on it has changed.
SAWS is no longer, and the community of San Antonio, therefore, is no longer entirely relying on the Edwards aquifer. The Edwards aquifer is a miracle of hydrogeology. It's always going to supply the lion's share of our water for our community, but it's vulnerable to drought.
San Antonio has invested in 8 different water supply projects that can now supply up to 30% of the city's water needs right now.
One of the coolest things that SAWS has done is develop something called aquifer storage and recovery. We can put over 40 million gallons a day from the Edwards down into a different aquifer in South Bexar County into that water bank. We have nearly a half a year's supply stashed away in that water bank, and we can bring it back to the tune of 60, 70 million gallons a day and take it to 2 different areas of town now.
Finding alternate water supplies for the city is important. Wise use of the water that we have is equally important.
Conservation is actually the biggest water supply project San Antonio has ever done.
San Antonio has been one of the best examples of conserving water. Over the past 20 years or so, population has increased by 40 or 50%, but the amount of water that's being used by the greater San Antonio community has stayed about the same. And that's impressive. Trying to predict droughts and their duration is a challenge. There's a number of efforts underway to help bring some understanding to that, but it's just a huge problem.
The key to understanding the variations in our climate can be found in the connection it has to the ocean. The ocean is the primary driver of climate. Changes in the ocean can give us clues about the climate of South Texas and its drought flood pattern.
During a drought, you have less water that's being evaporated up into the sky. You have less precipitation that's falling back towards the ground and being absorbed back into the ground. If you have less moisture in the ground, eventually you have less that evaporates back up into the clouds. And so the whole process feeds off of itself.
The lack of rain can make populations more dependent on groundwater reserves as surface water quickly evaporates and levels fall.
So one of the concerns people may have is climate change, that if we continue to have these dramatic, very hot, dry spells interspersed with very wet periods, what does that mean for us? Well, that's a real challenge, and that's part of why San Antonio has been investing so hard in new systems for water.
Texas' dependence on groundwater is concerning some water experts. About 60% of all Texas water comes from aquifers, and about 40% of the water used by cities is groundwater, making the state the second biggest user of groundwater in the country behind California. A study conducted by researchers at Texas A&M University found that in the 1930s, the statewide average water level was 46 feet below the surface. When the year 2000 rolled around, the average water level had dropped to 118 feet below the surface. While no one is sure just how much groundwater there actually is available, we do know that we're pumping water out of the ground at rates higher than ever before.
There's no untapped water to any extent in Texas.
There's been some concern that Texas could experience the same drought problems that hit California in the past years. While both states are impacted by the El Nino-La Nina pattern, the water situation in California is not quite the same as it is here in Texas. California has a large water delivery system that is made up of about 1,500 reservoirs and numerous canals with some aquifers. This huge system was built to capture snowmelt and to control downstream flooding. Prolonged drought can limit snowfall and dry up the reservoirs quickly. Texas uses a number of reservoirs, rivers, and aquifers for its water supply.
We don't have that frightening prospect of our reservoir drying up right before our eyes that other communities have that are entirely dependent on reservoirs. We're not going to run out of water. You might be hearing news about other places in the world that are. That's just not happening in San Antonio.
The San Antonio water system has invested in many new projects that can now provide up to 30% of the city's water supply from sources other than the Edwards Aquifer.
One of the coolest things that SAWS has done is develop something called aquifer storage and recovery. So think of it as a water bank. We have nearly a half a year's supply stashed away in that water bank, and we can bring it back to the tune of 60-70 million gallons a day and take it to 2 different areas of town now.
One of the most impactful droughts in Texas history over a one-year period was the drought of 2011. Rainfall was limited to about 18 inches that year, with the Edwards Aquifer dropping to levels that we had not seen since the 1950s. The drought had serious impacts on the region that included wildfires. Drought conditions kicked the wildfire risk into high gear.
The hazard or the danger that you will have an ignition and a wildland fire is much greater after prolonged periods of drought. To start a fire, you need at least 3 elements. You need a fuel, you need an oxidizer, and you need a heat source.
Once those cedar trees hit a certain threshold of fuel moisture, we really see them pick up in fire behavior.
The big problem really begins once the tops of the trees start to burn and the wind picks up.
One of the factors that's very important is wind. If you have strong winds, that will promote, that will result in drying, and that will also promote the flame spread. Embers are extremely important, burning brands, because they can be carried downwind over very long distances. They can easily travel across highways or man-made fire barriers.
This is how wildfires spread to homes, and our ability to respond becomes overwhelming.
When there's a wildfire burning, you have multiple houses threatened. It's not like a response to a single house on fire. It's 30, 40, 50 homes all threatened at one time, and you're looking at maybe a 10, 20-man fire department. They don't have the resources to protect that many homes at one time. The issue is people. We're moving people into these traditionally wildland areas where fire is a natural occurrence.
Our climate is changing, and the severity and the duration of droughts are changing too. We are traveling a new road, and we'll have to plan for a future where droughts could be longer and more severe.
This has been a Fox San Antonio special.